Alright, so let's go ahead, and we're still going to be working with the law of sines, but we're going to be looking at case 2. That case was when we had two sides that were known and then an angle that's not included between them. So SSA, or what I playfully call ASS, right? So we'll try not to make an ass of ourselves when we do this. Okay. So first of all, why is this ambiguous? And the reason comes because of this fact, right? For supplementary angles, the sine of an angle is equal to the sine of 180 minus theta. Now, we kind of know that from our unit circle, right? Let's just take 30 degrees and the corresponding 150 degrees over there, right? So these guys right here are supplementary angles, right? And we know that the y value over on this side is a half, and the y value over there is also a half. And so so that's the first fact that creates this being ambiguous, because we know that the sum of the angles, right, if we are talking about the angles in a triangle, the sum of the angles equals 180, but it's very possible to have a sine value that has a value over in quadrant 1, but has another one over here in quadrant number 2 that basically gets the job done. And so because of the facts that that the sine is the same value in both quadrants, and we're within the 180 degree rotation, if you would, to stay within the bounds of the sum of the angles equals 180, that's why there's a possibility that there could be two possible answers, all right, to SSA situation where I have a side and a side and a side. Now the reason why, if we go back to 7.1, the reason why that wasn't a big deal is because we knew what angle BA or B was and C, so we could always find that third angle. That was ASA or AAS or SAA, right? Because I knew two of the angles, then I could use this to find the third angle, and then that allowed me to start with my ratios because I at least had one side. And so, you know, maybe the sine of A over A was defined, or the sine of B over B was defined, or the sine of C over C was defined, depending on what side was given. So in 7.1, that's why we ended up with one unique solution. But in a side angle situation, because we don't know, right, since we only know one of the angles, and that means that there's probably two possible triangles that might exist. Of course, maybe there's only one, and then sometimes we're going to find sometimes there's actually none. So we have our work really cut out for us when we're looking at an SSA, or what playfully I call an ASS, an ass. All right, so that is pretty much, I think the book goes through more mathematical reasoning. There I'm just kind of hopefully just giving you an idea of why the fact that supplementary angles have the same sine value, and therefore we could have a potential value for an angle over here, or a potential value for an angle over there, giving us two possible answers. So that is pretty much the reasoning behind it, a very layman's way of saying it, because again, I'm trying to keep things as simple as I can, because I know we're tired. In these SSA situations, there's basically the following possibilities. One is we get no possibilities at all. Our work, again, this theta I'm talking about could be A, B, or C, right? But one of those angles has a sine value that's greater than 1. And of course that's a range error, right? Because we know, right, that sine basically bounces back and forth between 0 and 1. So if I get a sine value that's greater than 1 in my work, then we know we're dealing with an SSA situation that's absurd, right? There's no real solution to it. If we're lucky, the sine of theta will be equal to 1, and so that just basically means that if theta is equal to 90 degrees, we're dealing with the right triangle. So we go back and just use our trig like we were normally doing to find the other sides. So that would be the nice situation, and of course this is what we've been dealing with for most of our semester. But then the ambiguous case, we could have one or two solutions if our sign is between 0 and 1. That means the sign value, right, is going to be defined, but because there's two possible answers, one in quad 1 and one in quad 2, we may have one or two answers there. And really what it comes down to is the rule again that alpha plus theta plus beta has to equal 180. So if we can stay within these bounds, right, let's just say that we have a theta 1 and a theta 2 that create this situation where we stay with a 100. Oops, I'm off the page. I just realized that. Right. So if we have two theta values that the sign value satisfies the law of sines, and right, they create a situation where the sum of the angles stays at 180, then I have two. But if we deal with a situation where maybe the obtuse angle is too large, right, or it creates a situation where this sum doesn't equal 180, then we're basically down to 1. All right, so I think, again, there's a lot of theory there. The book breaks this down in all kinds of examples, but hopefully I just kind of laid out some of the groundwork, made it simple, and I think the easiest thing to do is just start to look at examples, see how this is the case, that some cases will have no thing that happens. We've already calculated the one case where right triangles. We've done that throughout most of our trig class. So this is probably the one we're not going to see a whole lot of, but we're going to see none, we're going to see one, we're going to see two, and we're just going to keep playing around with, do I keep my sum within 180? If I do, then I have two, right? If I don't, then we have to throw one out and keep one in. All right, so that is basically, I guess to summarize this again too, if our sign is greater than 1, we know nothing exists. But if we end up with a sign value between 0 and 1, we know something exists. It's either 1 or it's 2, right? Based off of the fact that we have supplementary angles that work. Okay, so let's get to work then and kind of see how this plays out and go from there. I'll do that in some videos coming soon, since we just laid out all the groundwork.